Hello, everybody. I'm Kyle Cordes at Oasis Digital. You're at the Advanced Angular Lunch. We are online this month. We don't know how many more months we'll be online, but for now, we're just rolling with it, and it seems to be working pretty well. This month, we have Chris Hardin, who's going to talk about monitoring, managing your Angular bundle sizes, how to go find all the junk that you didn't know what is in there and get rid of it. And it seems like the tooling is pretty good around this. So I've last seen it in a short demo. So I personally am very excited about this one. I hope everybody else enjoys it too. And I'm going to try to keep my video and sound off, ask everybody else to do the same so that we have Chris be the one who's on the recording. And then Chris, whenever you want to pause for questions, I welcome people, turn this stuff on. You will be published on YouTube asking your questions. So, don't ask anything proprietary. So thanks for attending, everybody. Hope it goes well.
Okay. I'll go ahead and get my screen going here. Okay. Get that out of the way. Okay. So hi, I'm Chris Hardin from Oasis Digital, and today we're talking about how to keep an eye on your Angular production bundles, specifically using Source Map Explorer, and then talking a bit about kind of what affects those bundles and how to address the issues that you find. First of all, though, why do we care? So the most important reason is the time to first paint. So, as you create a new Angular application and you start adding things to it, by default, everything, all of your source code, the Angular code, third-party libraries, they all get added into one big main bundle. And your user has to sit there and wait for all of that to transfer over the network and to load up in the browser before they can actually interact with your page. So as your application grows, and particularly as you start pulling in third-party libraries, that time is going to become too great. And so then we need to start addressing how do we manage that code and split it up into bundles so that your user gets a faster first page load experience. Some other considerations, mostly for mobile devices, are the cost of transferring that code over the network and data limits, things like that. And also, if your user is only using part of your application, we don't want to fill up their device memory with lots of code for things they're not actually even going to use, or lots of third-party library code and things like that. So what can we do? So the most obvious thing is lazy loading. So when we're talking about building Angular applications, the first thing we just start talking about is lazy loading. So splitting up our application into lazy loaded routes so that the main bundle is smaller and users only load the code that they need. But that only actually works if we've made smart choices when choosing our third-party libraries. So when we start pulling in third-party libraries, we can be surprised by how they affect our bundles, because it really depends on the author of the library to have done things correctly, or done things in a way that allows tree shaking and code splitting in order for us to actually get much benefit from that lazy loading. And so that's kind of what I'll be focusing on a lot today is third-party libraries or even your own libraries and what makes them tree shakeable or not. And so we're going to use a tool called Source Map Explorer to actually look at our bundle output and identify the problem areas, right? So just looking at a third-party library, it can be difficult to tell what effect it really is going to have on your bundles. And so you always want to verify that by actually doing a production build and running a tool like Source Map Explorer to look into each bundle and see what the actual contents are. And that way we can identify problem areas. And so again, in the demo, that's what I'll be primarily doing. Once you've gone through this process with your application and you get everything checked in and whatnot, then a few weeks from now, a developer might come along and add in another library or something. And so we can use a feature of the CLI, the Angular CLI, called budgets, to warn us about any changes in our bundles. So just by going into our Angular JSON file, we can add budgets for a specific bundle or a group of bundles so that the CLI will throw an actual compile error or warning if a bundle exceeds a certain size. So this can notify us when it's time to go through this process again of running Source Map Explorer and looking for any new problems that have been introduced. Okay, so again, I'm going to focus a lot on libraries because that's typically where most of the problems are. So when I'm trying to either pick a library or look at my own library that I'm writing, I need to evaluate it based on size. Now, there are lots of other reasons, other things you should evaluate when looking at libraries, but we're just talking about size today. So when I look at a library, and specifically when I look at an individual package on NPM, because some libraries already ship themselves as multiple NPM packages, but specifically looking at the size of one NPM package. If one NPM package that you pull down is of any significant size, then we want to start looking at it to see, is it tree shakeable? Can we do code splitting on it? In other words, can Webpack look at it and split it up into smaller pieces? Okay. And so 2 questions we want to ask there is, first of all, what kind of module format is it distributed in? So if we pull down that NPM package and we look at it, does it include ES modules format? So ES modules is the newer format for bundling for modules. Some of the older formats like AMD and CommonJS, those do not support the same level of code splitting and tree shaking that the ES modules format does. And the difference between them as far as code splitting is in ES modules require static imports between modules, whereas AMD and CommonJS and some others, they allow for more dynamic imports of different modules. And so when you go to run a static analyzer to try to figure out what you can code split or tree shake, it's harder to reason about things if there's any level of dynamism in there. So with the ES modules format, because it's more static, we can do a better job of predicting the dependencies between modules and doing code splitting and tree shaking. That being said, even if a library does ship in the correct module format, it still may not be code splittable or tree shakeable based on how it's packaged. So how many entry points in ng packager terms does it have? So if you create an Angular library and the Angular CLI by default gives you the ES module format, if you structure it in such a way that it only has one ng packager entry point, it's still not going to be tree shakeable or code splittable because it basically has just one giant ES module. So we're going to want to use libraries that have configured themselves to have multiple entry points, or you can think of it as producing multiple ES modules so that we can pull in only one of them at a time into our output bundles. And so I'm going to demonstrate that to make it more clear what I'm talking about. So, we're looking at the library that we're pulling in. We also want to evaluate any libraries that we write in that same fashion, make sure we have multiple entry points if we have a library of any size. But also, once we've looked at a library and, the way it's distributed seems fine, we also have to be very cognizant of any transitive dependencies that it's going to give us. So, this library is tree shakeable and great, but one of the components depends on something that is a massive third-party library that is not tree shakeable, okay? And I'm going to demonstrate that in a few minutes. So if that's true, we're going to have little control over that, and we might want to choose a different library to use. And my last point down here is, even if you're pulling in a large library, and you're like, well, you know what? I intend to use every feature in this library, so why do I care about tree shaking? But the point is, you're probably not going to use every feature on the same page. Your application's probably going to have multiple routes, and you're probably going to be using some subset of the features on any given route. So you don't want to have to load the entire library all in the same bundle. So you still want to make sure that the library is provided in such a way that Webpack can do code splitting. In other words, it can identify which parts of that library are used by which routes in your application and bundle those pieces together so that users aren't waiting for the entire library to load before they access any one of your routes. Okay, so I'm going to go to the demo portion here. Okay, so as usual, I went to the Angular IO website and downloaded the Tour of Heroes application as a starting point, and then added some stuff to it. So the demo code is available on my GitHub, starjumper30, TOH bundles demo. If you look at the README file, I do have a link to my slides as well. Okay, so I'm going to go to WebStorm here. Okay, so starting out where I've pulled in the zip file from angular.io with the Tour of Heroes application. And so that's a standard CLI application where the default project here is just directly under source. This is the Tour of Heroes web application. And what I've done is I've actually added a small library project. So from the terminal here, I just did, ng generate library and called it UI widgets. So by default, the CLI is going to give you a little library project here with this structure. And so the structure it gives you is we have a source folder and a lib folder. And under source, we have this public API file. So this public API file, this is the root entry point for your library. So the CLI just gives you one ng packager entry point, the root. And you put all of your code references in here, right? So in this library, I actually have two Angular modules because I have two sets of components. I have a couple components here under details. So I have a details module. And I have one component here under retirement. So I have a retirement module. So I have two independent Angular modules. They don't reference each other. But I do have them in the same library project. So they're both exported here in this public API file. Okay. So that means that this library is not in any way tree shakeable, and Webpack cannot do any code splitting. So even if I only use a component from details, I'm still going to get all of the code in this library bundled into my application. There's no way to avoid that. Okay. So I am using this library in my Tour of Heroes project. So if we go here for a second. Now, by default, when you download the Tour of Heroes, it's not using lazy loading or anything like that. So if we look at app routing, you can see we're directly loading components. And it just has one module, the app module. So here in app module on line 6, I've imported the details module from my UI widgets library. I'm not importing the retirement module at all. I'm only using the details module. And I'm loading that up here in app module. Okay. So it looks like, I've got a pretty decent situation. I have a little application, I have one little library with a couple components in it, and I'm just using like one or two of them. So what I want to do now is actually set up Source Map Explorer so I can double check what's actually happening when I go to production. So the first thing I want to do is actually install Source Map Explorer globally. So here I would just do npm install -g and Source Map Explorer. Okay. So I install the tool globally. Then I'm going to make a few configuration changes in my project. So for my, let's see, yeah, okay. So I'm going to go to my angular.json file and go to the configuration for my web project. So this one here, this is actually the Tour of Heroes web application. And so here under build, I'm going to find my production configuration. So I want to run the analyzer tool against my production output, see what my production bundles will look like. But I want to make a couple changes in order to work well with Source Map Explorer. So I'm just going to copy and paste my production configuration. And I'm going to rename it SME for Source Map Explorer. And I'm only going to change 3 properties here. the first thing I must change is the source map. So source map explorer analyzes your bundles by looking at the source maps as well. So I have to set that to true. There's two additional flags I like to change just to affect the names of the bundles. So output hashing, I'm going to set to none. And that just turns off that cache busting hash in the file name. And then named chunks, I'm going to change to true. And that will give me nice file names instead of the numbers that you usually get in a production build. So none of those changes should affect the actual bundle output other than the file names and giving us source maps in addition to our regular bundles. Okay, so I now have a special configuration for running Source Map Explorer. So what I need to do is build my web application with that configuration and then run the Source Map Explorer tool. And I'm going to go ahead and add in a script to package.json to do that. Let's call it SME here. So I'm going to do an ng build -c equals SME. And then I'm going to go into my dist directory. So Tour of Heroes is the output folder for this web application. And then I'm going to run Source Map Explorer, which again I've installed globally, if I can type it here. And it uses a glob pattern, so I can run it against star-es2015.js. So it'll look at all of the ES 2015 bundles in my dist folder and generate some results for that. Okay. So what do I have to do? Well, first I have to build my library project because that's the way the CLI sets everything up. So, and I've already done that. So here to build my library, I did ng build UI widgets. And you can see looking at this output from ng packager, it built one entry point called UI widgets. We're going to change that in a few minutes and we'll see how the output changes. So we have one entry point that is not code splittable. So then I'm going to run my SME target here. So npm run SME. And what that did was built my web application with the SME configuration and then launched with Source Map Explorer. So when Source Map Explorer launches, what it actually does is it creates a temporary file and then loads that into the browser for you. So actually, if I ran this, it would actually pop up into Chrome for me. I went ahead and did it ahead of time. So that would be this tab here. Okay. So this is the output from running Source Map Explorer. So when it first launches, what you're seeing is the combined output of all the bundles. If we look at this bundle drop down here, we can see we actually have three bundles. We have the main bundle, polyfills, and runtime. So main is where our source code, the Angular libraries, RxJS, and all our third-party stuff is all going to be here in this main bundle right now. You can see it's fairly large, over 600K. And so here we can see main, it's taking up kind of the whole screen here. If I click on any one of these, it kind of drills down to it. You can see that the most of our code is actually coming from node modules. So any library code is going to show up here underneath node modules. And you can see that 92% of our application bundle is actually third-party libraries. And if we look at this, we can see that Angular is accounting for 33%, 235K. And we have, RxJS down here, the in-memory web API, the Tour of Heroes uses down here. If we had more source code, we would actually see that in here. Right now, the source code is such a small percentage that you can't even see it in this visualization. But the big surprise here is that over half of our bundle is actually the Moment library. So that's surprising, right? So where did Moment come from? And why is it over half of our application? Well, if we look at our code, and so I'm going to go to my Tour of Heroes app, and I'm going to look for Moment. So it's not there. And if I go to my UI widgets library and I look for Moment, it only exists in one place. It exists in that retirement forecaster component. So this retirement forecaster component imports the Moment library to do one line of date calculation. So this one line of date calculation in a component in a module that I'm not even using is suddenly doubling the size of my application output. Okay. So how can I fix that? Well, right now, if I think about it, since I have control over this library, I can actually just go ahead and fix the library. I can't fix moment, but I can fix the library. So as it turns out, since I'm not using the retirement component, by fixing the library to have multiple entry points, I can allow Webpack to actually tree shake that away for me. Okay, so right now I'm adding this code splitting and tree shake ability to my library, not because my library is big, but because it depends on something that's big. So I'm going to go ahead and do that. Okay, so again, looking at what the CLI gave us, what the CLI gave us isn't actually well set up for defining multiple entry points. It gives us this kind of deep folder structure with the source and the lib. And if we try to add multiple entry points here, it's actually going to give us really funny looking imports. Because what I really want is I want each of these top level folders, these Angular modules, to be its own entry point. And so if I were to set up ng-packager to do that right now, I would end up with an import statement that looks something like UI widgets / source / lib / details. And so that's a really funny looking name for a module. So I'm going to actually first flatten out this folder structure and then add in my ng-packager configuration so that I end up with a separate entry point or separate module for each of these top level folders. So I'm just going to go ahead and take everything under source and move it up directly under UI widgets. And I'm just going to get rid of, well, we'll see if I can get rid of the source folder. Oh, it actually did it this time. Okay, so now I have a flatter structure. And so I just need to go in here and fix a couple things. So anywhere where I had, well, not there. I think that one, yeah. So anywhere where I had source, I'm just going to take that off. And that's fine. And this one, I'll go ahead and do this for a moment. I'm going to change that in a moment, but I think this one's fine. And I think I have like one more. Okay, so it should be fine now. Just get rid of all this stuff here. Okay, so I just flattened it out a bit. Okay, so I haven't really changed anything yet. So again, I said earlier that this public API, that's the root entry point for ng-packager, and that's what gives you an ES module called UI widgets. But what I want now is to have two additional entry points, one called UI widgets / details, and one called UI widgets / retirement forecaster. So I'm going to go into each of these folders, and the first thing I'm going to do is actually rename the index file to public API.ts. Okay, and then I'm going to copy in an index file and a package.json file. And these are exactly the same for each of these folders. So I'm pasting it into retirement and I'm pasting the same two files in under details. So I would do this for every folder that I had in here, every folder at this level. And so the index file is really just pointing to the public API file. And then the package.json is just adding in this ng-packager config. And so here it says entry file public API is referring to this local one. Okay. So ng-packager automatically looks through the folders in your project, looking for any additional entry points. And so when I go to build the library, it'll automatically find these package.json files down here and see that I have an additional entry point. Okay. So now I believe, okay, so I have one more step. So I've set up these entry points, but right now my public API at the root level, it directly references these files. So if I were to build it right now, it would create 3 entry points, but the root one would be kind of a trap. So if I built it this way, any user that imported from just UI widgets would get the whole library and would not be code splittable because this file directly references the code. But if you imported from UI widgets / details or UI widgets / retirement forecaster, then you would get just that portion of the code. So it would be code splittable in that way. But we want to make sure that nobody accidentally imports our library in a bad way. So we're going to make it easier on the user by changing this root entry point to really just be a reference to the other entry points, and that will make it code splittable. So we can't have these direct file references. Instead, we're going to reference the other entry points. So our library is called UI widgets. So the entry points that we now have look like this. So by changing this root file to reference other entry points, it is now splittable. Okay, so now, unless I've forgotten something, if I go to run, build my library again. So ng build UI widgets. Again, I didn't change any Angular JSON config. I didn't do anything else. I just rebuild the library, and ng packager will automatically pick up those additional package.json files. And so now you see the first entry point that it builds is actually called UI widget / details. And then it builds retirement forecaster. And now it builds UI widgets. And again, UI widgets at this point doesn't actually contain any code. It just points to the other modules. And that's what allows it to be splittable. Okay, so at this point, I've changed my library setup. I don't need to change my application at all because I set up UI widgets to be splittable. I don't have to make any changes to my web application. I just need to rebuild it. So here I would run my npm run sme target again, which again just does the ng build with the SME configuration and launches source map explorer. But again, I've already done that. So going on. So this is the output now after having made my library splittable. And so you see my combined output dropped from 6 something to only 341 KB. Okay. And if we look at our main bundle and the node modules, we now see that Angular is taking up 68% and that moment library is completely gone. Okay. So looking at what we have here now, we're in really good shape. Angular is most of it. Angular, RxJS, okay, we're using all of this stuff. There's really not much more we can do at this point with this application. Looking at the Angular stuff, you know, we have core and router. The only thing I can immediately see here that we can improve slightly is the forms. So only one of our routes actually uses Angular forms. So by adding lazy loading to our application, we could defer the loading of forms until later, into a later bundle. Right now it's in the main bundle, so we have to load it before we even see the dashboard page, even though the dashboard page doesn't actually use the forms. So at this point, I remember I didn't even remember to actually demo the application. So let's see if I can still running here. Yeah, no. So, sorry, this, dang it. I can't access the top of my windows. Here we go. Okay, there we go. Let me go ahead and serve this real quick. What is going on? Okay, that's weird. Okay, well, ignoring that for the moment. It all worked earlier, I swear. I do actually have a running version over here. So just because I remembered something, I forgot to actually demo the application. So Tour of Heroes, which you've been coming to Angular Lunch, you've already seen 500 times. But so here we have the main dashboard route, which doesn't have any actual form stuff on it. It does have this hero search field, which is actually now a component coming from the library. So when we load this dashboard route, we are going to be loading the details portion of the UI widgets library, because this guy here is actually coming from the details module from the UI widgets library. Okay. But as far as, say, the Angular Forms API, that only shows up when we go to the details page. So this detail route is actually the only route that requires Angular Forms. So if we add lazy loading to this application, we could make a slight improvement by moving the Angular Forms API out of the main bundle and into just the bundle needed for this detail route. And we'll do that in a few minutes. Okay, so where were we at? Okay, so this is our current state of affairs right now. Okay, so we are pretty happy. We could add lazy loading for the forms thing, but it wouldn't really gain us all that much. Okay, but now we wrote that retirement component for a reason. We actually, we have a story to go ahead and add that feature to our Tour of Heroes application. So we want to add, and so this what I'm writing here is actually the final product. We want to add this link here, retirement, to the detail page. And when we go to the retirement route, we want to show that retirement component, which has calculated a retirement date using that moment library. So now we actually do need to add moment because we do need to use this component. So I'm going to go ahead and add that in. And at this point, I'm just going to start using Git to skip things. Okay. So from now on, I'm not actually going to make any more changes to the library. I'm just going to be making changes to my application. So here, I'm going to go ahead and skip forward to where I've added a retirement route. Okay. Get rid of some of this stuff. Okay. So here I've added a retirement route. If we look at my app routing module, I haven't done lazy loading yet, so I just have a hero retirement component. And in here, he's going to be using that retirement forecaster from the library. So in our app module, we are now importing both details module and retirement module from UI widgets. Again, we could actually import these directly from, say, details like that, but there's no reason to do so. Because of the way we set up our root entry point, we can do this and it's perfectly fine. So if I build this and run Source Map Explorer, I'm going to get back to, I think, this tab. Okay, so now I'm back to where I was before, because now I actually need to use that retirement component, and code splitting isn't helping me because I'm actually using all of it, right? So I've made all the changes I can make to my library. Now I need to start making some changes to my application. So I can't avoid the fact that moment is coming in because I need to use that retirement component. Let's assume for the moment that I can't change it. Okay, so now I need to start thinking about, well, how can I at least get it out of my main bundle, right? So now this is when I start using lazy loading. Okay, so I've done what I could about the library. Now I've run a situation where I need to just kind of use lazy loading in my application to really just defer the cost of loading that component and loading the moment library. So if I go into here and I switch just the retirement route, because that's the one that's really causing me a problem. So if I go to where I have, just the problematic route lazy loaded, and then I, build and run Source Map Explorer again, then I'm in this situation. So looking closely at it, the combined total actually went up slightly, I believe. Yeah, because there's a little bit of overhead. But if you look at my bundles, I now have my main bundle dropped back down to only 49%. And almost half of my code is actually in this hero retirement module. So this is the bundle for my lazy loaded route. And so now moment has moved into that lazy loaded module. So I still have to pay the cost of loading moment for the retirement route, but the dashboard and all the other pages don't have to incur that cost. And so again, I'm looking at the combined total here. In this dropdown, I can navigate between individual bundles. So here you can see we have main, which is what's required to load the application at all. And then now I have this additional module for that one lazy loaded route. So again, this one's so large because it pulls in moment. Now, if I were to lazy load all the routes, let's see what that would look like. I have that here. So this is the source map explorer output when I lazy load all of the routes. So you can see here the main bundle didn't change much because my other routes weren't really that big. They didn't pull in anything large. So lazy loading all the routes didn't actually buy me that much more as far as improving performance. These other bundles are pretty small. So for each lazy loaded route, I have a separate bundle file. So here the heroes route is only about 2.5K. The detail page, the detail one, you can see that's actually almost 40K. If we look at that, it's because it includes the Forms API. So since that was the only route that used Forms, the Angular Forms code was delayed until this bundle. Dashboard is pretty small, mostly just source code. Here, once we get to the point where the bundle file isn't like 90% node modules, then you can actually see your source code. It's just that in the other bundles, the source code is so overwhelmed by the amount of third-party library code, you can't even see it here. But in this one, source is actually a significant portion. So you can see that we have the dashboard component, TS and HTML and all of that stuff. Okay. So there's also this one called common. So if we look at common, you can see that it actually contains the UI widgets details. So here you can see how our library, because we have multiple entry points, one of those entry points, the widgets details, actually ended up in this common bundle, whereas the retirement module, that entry point, got bundled into here somewhere, though I think you can't see it because it's so overwhelmed by moment. Okay, but the common one only contains the details portion of our UI widgets library. It also contains hero service, which is our source code for the application, because hero service is actually used in all of our routes. And there's some RxJS stuff. So this is a small bundle containing some code that's used by all or most of our routes. And so Webpack has split it off into its own bundle file. Okay. So here, this is, we're in a pretty good state. We've done as much as we can as far as, organizing our application with lazy loading and trying to improve our library with multiple entry points. So assuming that we need to use moment, that's the one remaining thing that kind of bugs us here is the fact that moment is still so large. So looking at this, why is moment so large? Well, using Source Map Explorer, we can see that the moment library itself takes up 353K, which is enormous. But if we break that down further, only 57K is actually the moment, the core moment code. 81% is actually just locale information. So these are all different locales. And so the majority of it is this locale data that we don't actually need. We're just doing a simple date calculation, and we don't need all of these locales. So how can we get rid of that information? And the problem is that Webpack and Moment don't play well together. But this is a solved problem. So somebody has actually published a Webpack plugin to actually strip out this locale data and allow Webpack to properly bundle moment without this extra information. And so we can actually add that into our CLI configuration. So I'm going to switch to that. Okay. Switching forward here for a second. Okay. So to fix the moment problem, again, we're not going to change our library because what we're changing here, what we're fixing is the Webpack bundling of our web application. So we're going to be fixing the web application, not the library. So first of all, we're going to install two additional dev dependencies. So the first thing we're going to do is install this Angular builder / custom webpack. So this is a custom Angular builder that allows us to supply additional webpack configuration for when the CLI builds our application using webpack. So we don't want to have to like export our application and build things ourselves. This custom builder will allow us to just supply some additional configuration on top of what the CLI already does. Okay, and the additional configuration we want, is to tell Webpack to use this special plugin, this Moment Locale's Webpack plugin. Okay, and so once we've installed those two libraries in our Angular JSON file, we're going to find our web application and go to the build section here. And this is the line that I've changed. So instead of the default CLI builder, we're going to use this Angular builder / custom webpack. And what that does is it allows us to specify one additional option here under options. So the rest of this is all the same as it was before, as it was generated by the CLI. The only thing I've changed is line 14 to add the builder, and then added in this custom webpack config option. And so what it does is it references an external JavaScript or TypeScript file that does just normal webpack configuration. So I added this file here in the root of my project. Okay. And so this simply adds some additional plugin configuration to Webpack using that Moment Locales plugin that I installed, and tells it to only keep certain locales. So now Webpack is going to strip out all the locales except for EN and US Spanish. Okay. So once I make this configuration change, all I have to do is rebuild my web application and run Source Map Explorer to see the result. So here's the result of running Source Map Explorer. And so now, let me go ahead and go to the retirement. So you can see the retirement bundle dropped from 300 and some K to 62. So here, Moment.js is now only 59K. And you kind of see the difference between these two files. So the Spanish, I believe, is adding about 2K. And then the Moment library itself is about 57. So we've now solved that problem as well. Okay. So that's it for the demo. Going back to the slides for just a minute. Okay. So on this slide, I have links to a few just open source repos that use this multiple entry point pattern. You can see these are all component libraries because that's kind of where you're most likely to need this. So Angular Material is a good example. The only difference with Angular Material is that they are using Bazel to build instead of using the CLI, but they are still using ng-packager. So they're just using Bazel to call ng-packager. So if we look at their setup, it's actually the same. So we go to Angular Material. They have changed things slightly between version 8 and version 10. I'm going to switch to version 8 for just a minute. And okay. So here under material, this is kind of the root of the material components. And so here you can see, folders, individual folders for each material component. And here at the root, you see that public API file. If we click on their public API, you can see how they're using that same pattern of so they're not referring to code here, they're referring to other ng-packager entry points. Theirs is scoped, so it looks a little different. So ours just said UI widget / the name of the thing. So Angular Material is published as @Angular/material, so we have that additional bit here. But this is using that same ng-packager formatting of referring to an entry point instead of the actual code. And then if we drill down into any of these folders, you'll see that same ng-packager type configuration that we had. So here we have the public API file that points to the actual code in this entry point. Now again, they are using Bazel, so it's a little bit different. But the index file and the public API file, those are being used by ng Packager to achieve the same effect that we were doing with the UI widgets library. Interestingly, when they switched, so in version 8 of Angular Material, you could just say, you know, import something from @angular/material, and it was fine because they set up that root entry point as just references to the other entry points. For some reason, I don't know why, if you look at their master branch, they've actually removed that. So if you look at the root in the master branch, they've actually removed that public API file, and their index file just has this comment. So starting with version 9, for some reason, they're not allowing you to just say from @angular/material. They're forcing you to do Angular material / and the name of the individual thing. So basically, they're removing that root entry point and only providing the kind of sub entry points. So again, so this is using the same ng Packager type setup as my UI widgets library, but they are using Bazel instead of the CLI. Going back to my list of examples, PrimeNG is another component library. If I open up that one, they're still doing things a little bit strangely. They're not using Bazel, they're using the CLI, but they've set it up a bit strange. They don't actually have their components in a library project. They have them as a directory here under app. It looks a little weird. But if you drill down into the components folder, you see kind of the same general ng Packager setup. They have a folder for each component. And at the root, if I find it, at the root, they have their ng Packager configuration. Instead of package.json, they've put it into just ng package.json. It's just two different ways of doing that. If you look at their public API file, again, you see that reference to entry points. And so they're distributing each component as its own entry point using the same type of ng Packager setup that we have. So if you drill down to each one of these, you can see they've got the public API and so on. And then the last one is NGX Bootstrap. And I said almost right because their root entry point is not splittable. And so let's look at why. So at first glance, you know, you look at this, we got all the different components and their own folders. If we look at each folder, you can see it does have its own ng Packager entry point. So that's good. So if I were to import from ngx bootstrap /accordion, everything would be fine. But their root entry point is not set up well. So where's the root here? Yeah. If I look at their root entry point here, I think is that. Yeah, so their root level is still exporting all the individual code files. So this would create a non-code splittable library. So for this one, you'd have to explicitly import from each sub module. So ngx bootstrap /accordion, not from ngx bootstrap, because they're not referencing the individual entry points here. Okay. These are some references. You know, reference to my GitHub repo, a little article about how speed affects users. The third one is Igor's keynote from ngconf, where he talked about Source Map Explorer and analyzing performance and things like that. The last one was the article I found very useful on how to set up your library using multiple entry points, and that's the approach that I'm using here. Oh, I just had a thought and I completely forgot what it was. Oh, yeah, so one thing I didn't address, so I know 2 lunches ago, Nathan gave a talk on, you know, producing libraries using NX. So, you know, we have multiple approaches to creating libraries here. So NX is good if you want to take your library and split it up into multiple small npm packages, or if you're using a mono repo and you don't need to publish things. So there's two ways to go here. You can produce one library that you publish to npm that just has multiple entry points in it, which is what Angular Material does. and PrimeNG does, and NGX Bootstrap does. So you don't have to go and actually npm install Angular /materials/mat table, right? You just install Angular material. And because it's using this multiple entry points feature, you still get that tree shakeability. So that's the kind of approach I was showing today. If you're not concerned about publishing or you don't mind publishing multiple libraries, the other way to go would just be to have really fine-grained libraries and have lots of them. So if you're going to do that, then a tool like NX for managing multiple projects in the same workspace would be useful for that. So neither one is right or wrong. There's just two different approaches that have different kind of pros and cons. Okay. But even if you're using NX with your libraries, then you want to make sure that either your libraries are so small that you don't care about code splitting, or that you do go ahead and add multiple entry points into each of those libraries as well. Okay, I'm going to, I think, stop the screen share here and see if there are any questions.
Yeah, I have one, or a few actually. You covered my Angular material one.
Okay.
That's my first one. And do you have any like pros and cons between Source Map and Explorer and the bundle analyzer?
Yeah. So I'm actually just quoting Igor here. So yeah, so people have been using Webpack bundle analyzer for a while. And then recently I saw Stephen Fluent and I saw Igor promoting Source Map Explorer instead. And when I tried them both out and I didn't really see much difference. But then in Igor's keynote from NGConf, he kind of went into more detail. And according to Igor, Source Map Explorer is just more accurate. He says that Webpack Bundle Analyzer somehow doesn't take into account the final optimization step that the CLI does. So the last thing the CLI does is run Cursor to optimize the bundles. And according to Igor, somehow Webpack Bundle Analyzer doesn't take that into account or something. So anyway, he said that Source Map Explorer gives you the most accurate sizes. Other than that, I tried using both of them and just using them feels about the same. So that's the only reason.
Awesome. And I have one more. Is there an easy way to tell if the library you're using uses the ES modules?
Oh yeah, I forgot to kind of show what that looks like. So really, I just end up first install the library and then look at what you get. So let me go ahead and share my screen again. I forgot to look at the output. So looking at the dist of the library. So here's my UI widgets library. And so you can see, a CLI library outputs a lot of stuff. So you can see here these ESM modules. I honestly don't know what the difference is between ESM and FESM here. But if you look at these, let's see, and you can see here, after adding multiple entry points to my library, you can see I get 3 things output here. So I have 3 ES modules. UI widgets, which is that root one, which if you look at it, see how it doesn't have anything in it? This file only has, it only exports those other module files. So this is how I know that it's totally code splittable, okay? Because this one's actually empty. It's just a reference to the other 2. And then the other ones actually have all the real code in them, okay? And so these are my multiple entry points. So before I added in those multiple ng packager entry points, if I had looked at this, I would have just seen this one file here, uiwidgets.js, and it would have had all of my code in it. And that is not tree shakeable. So this is kind of what you're looking for here. And so here in this ESM one, if you look at it, you can see I have UI widgets here, and then I also have this one and this one. So these are those different entry points. These are the actual modules that I'm pulling in. And so it's this level at which you can actually split things. So yeah, I mean, if it's kind of either installing the library and trying to look at what you have here, looking at their GitHub repo, if it's open source and trying to see how they build it, and then ultimately just experimenting with it and running Source Map Explorer to see what you get.
Awesome. Thanks, Chris. That's really, really good.
Thanks.
Okay, Chris, I've got a question here. The first is, it feels like the overall size is still pretty big, even after all the optimization for the simple app. And I thought there was something coming down the pipeline that was going to like shrink the Angular bundles to like only the subset of Angular features you actually used. Do you know, like, is that still coming? Is that in the box here somewhere? Like, what they don't feel as small as I was expecting.
Yeah, and I think I haven't looked into it that much, but just from like remembering the like graphs that they showed during the NGConf presentations, I think the problem is that you only notice a significant improvement on a really large application. Because if you look at the Angular stuff that we're pulling in, let me share this again, sorry. If you look at the Angular stuff, wrong thing. Oh, there we go, okay. Find it, just go to the last one. So if we look at our main bundle here, which has most of the Angular stuff in it, you know, so core is still pretty big. We're using the router. Yeah, I mean, we're not pulling in things like animations or some additional stuff. So I think if we had a larger application where we were pulling in more of the Angular, different Angular packages, I think we would see a more dramatic reduction. But yeah, you're right. It seems like kind of the basic core stuff didn't get much smaller. But I honestly haven't looked into it that much. I've mostly been focusing on the third-party stuff other than Angular.
And is this all using Ivy, I assume?
Yeah. So you can see here that it's referencing, like when we look at here where it says node modules and it's trying to tell you where the code came from. You can see here, like it actually says, so this is within a node modules folder. It's actually looking at that Ivy NGCC folder. So many of your Angular libraries, when you go to use them, that Angular compatibility compiler, right, it kind of pre-compiles them into that folder and node modules. And so that's where the code is actually coming from. So it's using the Ivy compiled versions of those libraries. It would be interesting to run this on a pre-Angular 9 app. I don't have that.
Well, we're kind of past our time, but any other questions for Chris?
I have one more.
Okay.
If no one else has one. So you showed how to use that that Webpack config plugin. So if I don't know how to phrase this, I guess if we come across something else that's not Moment, so that fix was made specifically for Moment. I guess we'd either have to like figure out how to augment that plugin.
No, so you can do, so I used I did two things, right? So one thing was just generic and the other thing was Moment specific. So so I installed a Webpack plugin for Moment, but what enabled me to use the Webpack plugin was this builder here. And so this builder is generic. So once I've got this builder here, I can add any kind of Webpack configuration. If I just need to set some additional properties, add in plugins, anything you can do with, well, I think, I haven't tried it, but supposedly anything you can do with Webpack, you could just pass on through here. So if you see what I did was, so using this builder, right, in my Angular JSON, it just allows me to pass in this additional file. And so back in the days of hand configured Webpack, which weren't not fun, your Webpack configuration was really just a large JavaScript file where you could import plugins and import code and then come up with this big, insane configuration thing that you pass to Webpack, okay? And so what this is allowing you to do is do a little bit of that old stuff in a JavaScript file, just like you would have back in the olden days. but you don't have to do the whole thing, right? So you can still take advantage of the fact that the Angular CLI generates a Webpack configuration for you. So we're just putting in a little bit extra. So we're taking the Webpack configuration the Angular CLI is going to generate, and this builder is just going to add in your extra piece onto that. And so you do that in this JavaScript file. So looking at this JavaScript file, this is just good old Webpack configuration. So if you wanted to do something extra, you could just go to the documentation for Webpack and figure out how to do something the Webpack way, right? And put in some additional stuff here. In this specific example, I'm passing in an additional plugin. But this Webpack configuration object, that's what this is. This is a Webpack configuration object. And you can pass in other things, other properties and configurations and stuff. And that would all be part of the Webpack documentation. Does that answer your question?
Yeah, definitely.
Okay.
Okay, well, we will call that the conclusion of the recorded program. So we'll wave goodbye to all the people that are watching on the recording.
Okay.